Welcome back. Now, in the previous video, we talked about how we need some sort of a key exchange algorithm. And this key exchange algorithm needs something called asymmetrical encryption. I know it's a lot to take in, but stick with me. Hopefully this little drawing will help you out. Now, unlike symmetrical encryption, an asymmetrical encryption uses two separate keys for encryption and decryption. So these red keys are owned by this blue laptop, and these blue keys are owned by this other computer. Now, these two keys are known as public keys and private keys. And together, these keys form a public-private key pair. And as the name suggests, these ones are public. So I can share this red key with anybody I want in the world. It can be out in the open. It's not a big problem. And same with this blue one. But these ones that are private, that are kind of in the shadows, these are your absolute secrets that you should never, ever share with anybody. Now, these public keys are linked with the private key in terms of functionality. You can see that they're both red, they're both blue here. The private key cannot mathematically compute from the public key. So what does that mean? The relationship's a little bit complex, but a message that is encrypted by a machine's public key can only be decrypted by the same machine's private key. And it's what we call a one-way relationship. So let me show you how it works. If I send my public key to my friend's computer, and let's say that friend also sends his public key to my computer, if I want to send a message, I can say, hello, send it over by encrypting it with his blue key, his public key. It's going to get jumbled up and encrypted like this. And when I send it over to him, well, now he can use his private key because this piece of text was encrypted by the public key. So the private key can decrypt it, do its magic, and then finally get the message, hello. So you see here now how we can send public keys to other people and bad people can grab the public key, but because it's one-way relationship, this public key cannot decrypt its own message, nor can it decrypt anything encrypted by a private key. It can only encrypt something, and it can only be decrypted by its paired private key. That, again, is never ever shared with anybody. Now, the strength of the entire connection lies in the fact that the private key is never relieved, right? All right, awesome. So that makes sense, right? A little bit more complicated than symmetrical encryption, but I think we get it. Now, if we go back to where we started, most people think that SSH uses asymmetrical encryption entirely, and that's not entirely true. This form of encryption with SSH is actually only used during the key exchange algorithm of symmetric encryption. You remember that, right? We need some way with symmetric encryption to generate that yellow key without it entering the public. What happens in SSH is that before we initiate a secure connection, both parties generate temporary public and private keys and share their respective keys to one another. And at this point, we're able to get these yellow keys, these symmetric keys, so we can exchange messages using something called the Diffie-Hellman key exchange. And I'm going to link to some resources that you can use because it is a little bit mathematically complex. But what it does basically is that it uses a bit of this information, a bit of this information, a bit of the public keys to generate, without ever exchanging the keys, each machine on its computer can generate this symmetric key from data from each computer. And again, this Diffie-Hellman algorithm, or key exchange algorithm, makes it possible for each party to combine their own private data with public data from other systems to arrive at an identical secret session key. Cool. I know that's a mouthful and I know that's confusing. Like I said, check out the resource after this video if you want to learn more about it. But by now, we should know how we're able to generate a symmetric key using asymmetrical encryption, using the Diffie-Hellman key exchange. And this way, this yellow key is going to stay private to us, and it's never going to touch the public. By the way, you might be thinking, all right, enough talk about SSH. This is getting boring, Andre. Come on, we just started the course. And trust me, this type of encryption is everywhere. You're probably using it right now. To watch this video, you're using Diffie-Hellman key exchange. And when you use your phone to do anything where it connects to a server, it uses Diffie-Hellman key exchange. And we should know how these things work, right? As a developer, we need to understand how things work, not just on the surface level. You might notice how it's kind of funny, right? The name key exchange is that we don't actually exchange a key because it would be out in the public, and we don't want that. We actually just share a piece of public variable, such as our public keys, from each computer, and we generate the key separately in our own private space. All right, let's take a little bit of a break, and I'll see you in the next video because I know that was a lot of information. I'll see you in that one. Bye-bye.